Today we're diving into the realm of serverless computing with AWS Lambda and API Gateway. Continuing with our office analogy, let's remember we had our cubicles Amazon would set up for us in under a minute, the Elastic Cloud Compute or EC2 instances, and we could rent them by the minute as well. But what if we only have a really small workload, and not only a few, but potentially a lot of them? So we need something that can appear at an instant, use it only to do our work, and that is fully disposable once we're done. The answer to that in the office world is easy: interns. And in the AWS world, we use Lambda and go serverless. But how does that work? After all,
we know apps have something to do with servers.
If that's so, how can we go serverless? Well, we aren't really, of course. With Lambda, we just no longer need to care about where or what server is running our workload, nor what its name is, so, like interns. Now, where do these tasks come from? Well, many places. We can set up events to trigger them automatically, like when a file is uploaded to S3, our giant storage facility, or we could set up a timer to call our Lambda function. AWS offers many possibilities, which we'll look into in later lessons. For now, we will talk about scenarios where we explicitly call our interns. A popular one is typing something in our browser. In most cases, this will connect us to something we call a REST endpoint. Have you ever looked at the address bar in the browser when you use Google Maps? In my case, it will open the map and show my hometown, Berlin. If I move the map just a little bit, the text in the address bar will change and a bunch of numbers appear. We see the domain google.de and /map/ followed by 3 numbers. Taking a closer look, we see these are the GPS coordinates of Berlin, and the 14 is our zoom level. Now, what is actually happening is that our browser is making REST calls to Google requesting new information about what to display. We can even take a look. If we hold Shift and right-click on the map, we can select Inspect and go to Network. If we move the map again, we see a bunch of new lines appear, and if we click on them, we see that there are many different endpoints that Google Maps calls for the website to function. So, why am I telling you this? The reason is that most websites work this way, and we can use Amazon API Gateway to very easily and conveniently define these endpoints and connect them to Lambda functions. Let's go back to our office analogy, and imagine Chris, the customer, comes in with a filled-out request form, and gives it to Anna, the API Gateway at the front desk. Anna will check the form for any obvious mistakes, like mandatory fields not being filled out. In this case, Anna puts a red stamp of denial with a number like 400 and gives it back to Chris, the customer. So Chris fills out a new form, this time correctly, and Anna, the API Gateway, passes it on to an intern that now quickly processes it and hands the results back to Anna, the API Gateway. She gives the stamp of approval with a big green 200 on it and hands it back to Chris, the customer. Now, Anna, the API Gateway, could have also handed it to a number of other AWS services, including an application running on an EC2 instance, but Lambda is the most common use case. Okay, let's look at what a question in the exam might look like. Question 1. A company has developed a new service using AWS Lambda to process requests. They need to expose the service over the internet and provide a RESTful interface. Which AWS service would help achieve this? A. S3, B. EC2, C. VPC, or D. API Gateway? A is wrong. S3 is for storage. EC2 is also wrong. Remember, they were our cubicles and can process data like Lambda. C is also not correct. VPCs were our company telephone system. D is of course correct. This is what API Gateway is perfect for. Let's do another one. Question 2. A web application is designed to respond to a specific event where an object is added to an Amazon S3 bucket. The application then needs to process the object and store the results in a database. Which AWS service can help achieve this without managing servers? A. Amazon EC2, B. AWS Region, C. AWS Lambda, or D. Subnets? A is wrong. EC2 instances could run an application to do just that, but we would need to explicitly take care of our server, ensure it is running, the application is installed correctly, and make sure it is not overloaded with too many requests. B is also wrong. Remember, AWS regions are the groupings of our availability zones, which are buildings that house our cubicles in the analogy. C is perfect. Lambda functions can be triggered directly by an S3 event and talk to a database of our choice. D is not correct. Subnets were part of our VPCs, so a part of our company telephone system that is concerned with one particular availability zone. Okay, let's sum up what we've learned today. With traditional servers like EC2, we need to provision them and pay for the time they're running. If we have lots of smaller tasks, we can take an easier route and use AWS Lambda functions. With Lambda functions, we neither know nor care what server is actually running our code. All we need to know is that some capacity will be made available at an instant to do our work. There are many different ways to run these functions, such as triggering them from S3, putting them on a schedule, and many more. The most popular way is using API Gateway. API Gateway allows us to easily and quickly set up so-called REST interfaces that can be called from everywhere on the internet.